University. So in this video, I'm going to give you an introduction to Vyper and Brownie, because these are topics that people ask me a lot about inside of the program, and I want to make this video for you today to explain what they are, why you might want to know about them, and how to get your hands dirty. So before we get into that, just a quick reminder, we have got the Collectibles Masterclass. That's going to come up next week. All right, so that's going to be on Wednesday, February 24th at 5:30 p.m. Pacific time. All right. So we will put a link in the general chat to the live stream so you can join. If you can't make it in time, don't worry. We'll put a replay inside the video vault that you can access, as soon as we finish. So inside the Collectibles Masterclass, I'm going to show you up on this big trend that's going on right now in blockchain with DeFi, or sorry, with DeFi, with NFTs. All right. We've seen products like Hashmask come to prominence. Hashmask sell for 420 Ether. Lots of other collectibles like CryptoPunks or just Ether cards are just going through the roof. All right. So I want to help you jump on this trend, show you how to create your own digital collectible website, smart contracts, deploy it to the Ethereum network, also a sidechain for scalability, cheaper transactions, all that kind of stuff. We're going to have a guest NFT master on the stream, so make sure you check that out. All right. Super excited. So let's talk about Vyper and Brownie, all right? Because these are two things that you might want to add to your blockchain development toolkit. People have requested this, so let's jump in. What are they? So Vyper, first and foremost, is a programming language, all right? So Vyper is a programming language for writing Ethereum smart contracts that's like Solidity. So essentially, it's an alternative to Solidity. It looks a lot like Python. It's invented for security. Also, it's a simpler syntax and makes it easier to audit, okay? So Brownie is a framework. It's a Python-based framework for developing Ethereum smart contracts. It supports Vyper and Solidity. But one of the biggest reasons you might want to use it is for Vyper support out of the box, okay? So essentially, Vyper is an alternative programming language for creating Ethereum smart contracts, and people requested this, so I'm going to show you how to do it today. And then Brownie, if you want to use a framework to create those smart contracts, write tests against them, deploy them, Brownie is a framework that lets you do that out of the box. So let's look at a few prerequisites for doing this. We'll support Mac/Linux and also Windows here. So let's see here. All right. Sorry, pull up my terminal. The first thing you need to do is install Homebrew. So if you're on a Mac, you need some sort of package manager. So if you're on Mac, Homebrew is definitely a good way to go. You'll need to install Ganache CL. You'll need Node.js installed. All right. So most people watching these videos have been following along already. You probably have these things. Node npm is a package manager that comes with Node. All right. You can use this one's called Ganache CLI. This is going to be our blockchain that we run in our terminal. Okay. So if you can see if you have Node already installed, make on your terminal, type in node-v. This should work on Linux, Mac, or Windows. Okay. All right. And so I'm going to change Node versions here actually. So I'm using N. I can do that pretty easily. So I'm going to use Node version 10.19.0 just to make things seamless. All right. So if you want to install Ganache, you just do npm install or I, so -g Ganache CLI. All right, so this will install the Ganache CLI version blockchain to your global node modules, and you'll need Python installed. So I can look and say Python. I think it's, let's see here. Okay, sorry, actually it's -v. I think it's, yeah, sorry. So another how it works in Python. So Python-v is Python 2.7.6. So I'm going to change my Python version here. All right, so I've changed my Python version here. So if you're on a Mac and you want to change your Python versions, like I was showing you Python-v, I have the wrong Python version set here, where you need this version or higher. Then you can change versions pretty fast with PyEnv. All right, so this is an environment management tool for Python. You can just go to github.com/PyEnv/PyEnv. That's the organization. This is the repository. And this is a Python version manager. So if you want to jump between an old version of Python and a newer one, sometimes you need different Python versions to run different programs, run different environments, all that kind of stuff. Okay? Then that's what you can use. You can use PyEnv versions plural, and you can just change between the versions like this. And now I can just run PyEnv global 3.7.3. Okay, now I do Python-v or PyEnv versions. There we go. And you might notice that the version didn't change here when you run Python, so you can do this from the PyEnv repo. You can just do eval, all right, PyEnv init, and then Python -- version. All right, so it's changed. Perfect. All right, so now we've reconciled Python, so that took a few seconds. Now we can get back to the installation process. So if you're on Windows, I highly recommend using Windows Subsystem for Linux. All right, there's some videos floating around on how to do that. You can check with Peter in the chat room. He's definitely the master on this. So if you have Windows Subsystem for Linux, then 3.6 should be available. So after you've done all this, here's the instructions for Windows and Linux over here, and then the instructions for Mac. So basically, everybody who's on Linux and Windows is basically doing the same Linux commands. So for Mac, I'm just going to install it this way. So brew install pipex. All right. Okay. And so if you're on Windows or Linux, and you're using Windows Subsystem for Linux, it's sudo apt install pipex. That's the package manager, just like this. Then you'll need to install sudo apt install python3-pip. Okay. Sudo python3-m pip install user pipex. Then sudo apt get install python3-venv. And either way you do this, you need to restart your terminal here. Okay. So well, actually, these steps right there didn't work. Okay, so I'll put a link in the description below. So this is what you can do here, and if it doesn't work, then you can do these things. Okay. So also reach out in the chat to Peter if you have any particular issues with Windows. He's definitely the Windows master, whereas I'm more Mac Linux guy. So you need to restart. Next, you want to check on the installation. So I'm going to go and restart my terminal here. Okay. Try this Python. Okay, so I need to actually restart mine really quickly. Let me just fix that. And next you can install ETH Brownie like this. So pipex install ETH-Brownie. You see this loading message here. So we'll wait for this to finish. All right, so it's done. So install package ETH Brownie 1.13.1, Python 3.9.1. All right. So yeah, there we go. Let's move on. All right, so now that we have gone through our grueling setup process, let's go ahead and make a new directory. So we'll say mkdir, so make dir ETH-Brownie-test. You can really call it whatever you want to, but now enter the directory like this. Okay, and we will create a new project like this. So Brownie init. It looks like I didn't know about Brownie, so I need to run this command, pipex ensure path. Okay, so that actually updates the path variable to include this. All right, so for the actual binary. So I have restarted my terminal, and I've done Brownie init again, and it worked. Okay, so if you have trouble with this, you may need to restart your terminal. You may need to check your path. Okay, it's gonna be a little tricky. It's a little even tricky for me getting this set up. That's just kind of the case of environment management. It's kind of always tricky. That's just the pain of being a developer. So let's continue on here. We've got Brownie init that creates the project. So now let's actually get their Solidity token example. So we can do Brownie bake token. All right. Okay. Click less. We can see that there are files in here. So we can open this in Sublime Text or whatever text editor you like. So now you can see we got contracts, interfaces, all right, everything that you need for a project inside here. You can see token. All right. So contracts, token.sol. So this is a Solidity example. This is an ERC20 token. If you build any of the ERC20 tokens in this program, this should look really familiar. All right. We can see how we can interact with this. So we can get React. You can add React to a project like this. So Brownie bake React mix. All right. Boom. There you go. We can open this into the project like this. Let's see here. Click React here. You can see a Vyper contract inside of here, a Solidity contract. These are basically both storage contracts where you can create a full stack application and see how it's built. We're going to go through this in a second. I'm just going to show you the examples. All right. We can get their ERC20 example. So, tell you what, let's do this. All right. So this, up to this point, is really showing you how to set up Brownie on your computer. Okay. How to install it, how to create a brand new project with Brownie init, how to pull in some of the Brownie packages with React Bake. Okay. So you can do React Bake token that pulls in, these Brownie recipes basically. This token. So you can browse around here, see the tokens, how they work, all that kind of stuff. So what I actually want to try to do is build a project, build a smart contract with Vyper, test it, on a blockchain, also deploy it. Okay. So let's do that. Right. So basically, you've seen how to create a new how to install Brownie, how to create a new project, how to pull in these pre-made recipes. So that'll give you that idea. But let's actually create a project like this. So let's do a full one. Let's clone this from GitHub, from the DApp University repository. So I'll make this public so you guys can do this. You can do git clone Vyper ERC20 tutorial. Okay. So this should be in the instructions. I'll make sure there's a link to this in the description below. So cd Brownie. Okay. Brownie Vyper ERC20 example. So we're gonna use the Vyper programming language. So we can enter in the directory like this. We've already done that. We say Brownie compile. So compile the contract. All right, so it worked nice, easy out of the box. Let's go ahead and open up the text editor, take a look at the code. So you can see the directory structure here. All right, so we've got the contract directory. This is where the Vyper token will go. The interfaces will say a minute, the scripts, all right, the test as well. Okay. So let's just start with the contract. So this is Vyper. All right, looks a lot like Python. If you've seen Python before, you'll notice this import at the top. It looks very much like Python. Okay. You can see this here. So implements ERC20. All right. You can see the events here, just like Solidity supports events, so does Vyper, and this is how you declare an event. This isn't actually called the event, but this is the transfer event for the ERC20 standard. But the ERC20 standard is just a description of how a cryptocurrency should work that's deployed to Ethereum, that's governed by smart contracts, that's supported by wallets, exchanges, all that kind of stuff. It requires that you implement these events. So here's the transfer event, here's the approval event, when people approve other platforms to spend their tokens, the name of the token, the symbol, the decimals, so you can see how the variables are declared. These are basically the state variables, okay? So a state variable, it's public, it's a string, 64 bytes, a symbol, which is also a public string, decimal, which is a public string. So if you compare this like side by side with the Solidity example we saw a second ago, let's look at here. Sorry, I'm pulling up the other project here. Here it is, all right. Pull this up and you look at the, you can go to token, contracts, token.sol. Here's the Solidity version where you see your contract token, and then you see the events inside of here, like the, the transfer event, the approval event. So this is how you define an event inside of Vyper. This is how you do it inside Solidity. This is how you do it inside Vyper. You have these public state variables inside of Solidity like this. Okay, string, public symbol, string, public name, uint, public decimals. So same thing here, string, public name, string, public symbol, string, public symbol, right? Same thing here. You have the mappings here. Here's the balances. Here are the balance like this. All right, here's the allowances, okay? All right, so you start to get the idea of how this works, okay? And if you've coded in Python before, this works like that, where it's a white space dependent language. I'm not going to get totally off into the weeds on coding everything inside of Vyper, because I primarily code in Solidity anyways. But a lot of people are asking, like, hey, how to set this up, how to use it. This is meant to be mostly the introduction on that, and kind of explain the differences between languages, how it works. See, this looks like Python. We're doing a self.name, right? This is basically assigning the state variables that way, all right? See, log, this is how you emit events, so log transfer to the 0 address, which is a, that's actually in there, yeah, totally, okay. And message sender, so we tell the message global variable, initial supply, which is calculated here, right? So that's how you create the constructor, all right? So we have constructor inside Solidity like this, but we have this init function that's external. That's how it works in Vyper. Here's how we create functions for like total supply, right? A view function, so you're just reading information. Total supply like this, so you define it with def, right? Sending def here, but you have a special init function here. So allowance, view function. So here's an external function actually creates a transaction, which is transfer. So it's just the same, you just call it external. It's not a view function though. So let's see here. Ooh, transfer to. Here's how you pass the arguments, all right? So you still declare the types, statically typed just like Solidity is, returns a boolean, all right? So this is the logic, it updates the balances, all that kind of stuff, logs the event. Okay, so I'm trying to see anything else that changes is different here. So no, that's the idea. That's how you create the functions. That's how you implement the business logic inside the functions, the view functions versus the functions actually create transactions, and then also the, let's see here, the visibility, all right? So internal versus external, all that kind of stuff, okay? So that's a side-by-side comparison of Solidity versus Vyper. If you want to dig into Vyper more and see like everything about the coding languages, maybe you want to like build your own project in Vyper, get all details, you can go to vyper.readthedocs.io and check it out there. It'll show you everything about the types of language, how to structure a smart contract, the data types, the variables, all that kind of stuff. Okay, just check out vyper.readthedocs.io for more information on that. So now we've seen a side-by-side comparison of the programming languages. Let's see how to do more stuff with the actual framework itself. So we've already compiled the smart contract before, but let's just do it again. So Brownie compile, all right. So I've already done this, but basically this takes the code and turns it from human readable code to machine readable code, all right. Gets ready for the EVM. So now we can run the tests like this. Let's actually start in our CLI. So let's start the blockchain, open a new tab, type in our CLI, and that'll start your development blockchain. And then do Brownie test. All right. So it works a lot like truffle test. You can see the tests here. So tests, they're written in Python. All right. So if you've written any Python before and you've tested any other applications, this will work the same way. It's using PyTest inside here. Okay. Similarly to if you use Mocha and Chai in JavaScript, that's how you write tests for smart contracts and truffle. So when you use PyTest like this, basically you just write functions and then you write assertions inside here like this. Okay. You can read more about PyTest on their documentation. You do assert. Okay. So if you come from a Python background, that's probably one of the biggest reasons you might want to use Brownie and Vyper. But yeah, you can see all that here. All right, so let's go and see what our tests are doing. There we go. They've all passed. So you can go and make one of these fail if you want to. You can change it to 1, something like that. Make it fail and then make it pass to kind of get an idea on how that works. So run the test very similar to Truffle. Okay. You can also see the amount of coverage. You test Brownie test dash coverage and see like what has coverage for it, what doesn't. Okay. And you can see that we're running this against our CLI over here. It's gone like crazy. So you can see 31% coverage. And these, what we're kind of showing over here. Yeah. All right. It'll give you a more verbose output on the coverage. You can see the percentages here. Okay. But now you can see this readout here. It's a contract token. All right. It'll show you all the functions and what needs to be tested and what has no coverage. So now let's deploy the contract. So you can see you do that inside of Brownie like this. Let's see here, deploy. So we saw Hard Hat the other day. You know how to deploy smart contracts that way with scripts. So you have a similar script inside of Brownie like this. So it's just a Python script. So you just import the token and the accounts from Brownie, and then you do this main function, and you do accounts 0 deploy token. You pass in the variables for the smart contract like this. Pretty straightforward, pretty simple. That's all. And you deploy like this. So you just go Brownie run deploy JS. So you're really running a generic script, but you're defining the deployment inside that script. It's kind of how Hard Hat works. You just have scripts. You create a deployment script, whereas Truffle uses a deployer, uses smart contracts, all that kind of stuff. This is just a different way of doing it. All right. So we can see that transaction was sent. We can open the Brownie console to interact with the smart contract like this. Brownie console. All right, and then now you have a Python environment where you can interact with the smart contract itself. And if you want to interact with contracts in the console, you do like this. You see the accounts first, the accounts. All right, there's the accounts on the network. So this is all in Python, so accounts 0. They give you your account you're connected with, okay? You can do accounts 0 balance. All right, that'll show your balance. You can do accounts 0, transfer. Accounts 1. You can do like 10 ether. All right. Oh, let's try that again, sorry. Accounts 0, transfer. And then, yeah, there you go, so accounts 1, and then 10 ether. All right, there we go. So transaction was created, and now you can see accounts 0 balance, and it's decreased. And accounts 1 balance has increased. Awesome. So you can interact contracts like this. You can say token, right? It's empty. And you can say token deploy, and then pass in the name. So my token. You can do whatever you want to here. MTK 18 1 to 20. And you can say like this. Oh, so that breaks. Sorry, I lost my place here. From accounts 0 or 1 doesn't really matter. Okay. So I should have done like this. So I want to assign it to T. Do it again. It's okay. Get multiple copies. Okay, so T is now the contract, and you can get the balance for the account. So T balance of accounts 1, probably 0. Yeah, so account 0. All right, so there you go. So that's how you get the contract. T equals, you get to deploy a new copy whenever you load the console. You get the balance of function called like this. Pass in the first account list, which is account 0, which we saw up here. And yeah, there you go. It's got all these tokens. So we can call a transfer function. So T.transfer accounts. Let's just do it to account 1. Let's say 1 to 820. And then we do from accounts 0. And there you go. There's a transaction. Now you can do balance of account 0 is this. And then balance of account 1 is this. Awesome. There you go. So that's how you do a transfer function. That's how you create a transaction. Of course, you can see that here on the Ganache blockchain. And that's how you write Python commands. Just like you write JavaScript commands in the Truffle console, you write Python commands in the Brownie console against the smart contracts with Vyper. Of course, you could code them in Solidity inside this framework. If you just like Python and you're more of a Python person than a JavaScript person, then you can use this to code Solidity smart contracts inside this environment. And maybe you like this better. So that's what I want to show you today. So you can exit the console like this. And that's all I got for today. Okay, so I'll leave you some homework. If you want to put your contract on a public network, you can do it with these instructions. Of course, you'll need some sort of RPC URL. You can use Infura if you want to. But you can just do Brownie accounts new, give it an ID, add the private key like this, add the Infura ID, put your Infura ID here, and then you just run the deploy like this and you specify the network. Okay. So you can do some more homework. You can read about what the contract packages here. Okay. You can use the GUI. Okay, working with opcode, you can see it here. And then also contract analysis with Mythics, which is pretty cool if you're like auditing contracts with like static analysis. That's pretty cool. And then if you want more contract examples, you can follow this link and you can kind of, have fun with this CA wallet, voting, token, storage, stock, all that kind of stuff. Okay. So that's all I got for today. Hope you like this video. This is another example of something you can use to develop smart contracts. If you're just a Python person, you want to develop Solidity, maybe this is the way to go. Or if you just like, if you're a Python person, you also like, you just like Vyper. This is the way to go too. So don't forget the collectibles masterclass is next week, Wednesday, February 24th. Mark your calendars, and I'll see you then. All right, bye-bye.